Section 3.3, Types of Statements, Video 4. Before we get to the last part of the section, I want to address a side topic about writing the negation of a conditional. For example, let's suppose that I say the statement, if I have money, then I will buy a car, and that statement is true. If that statement is true, then its negation would have to be false. Remember, two statements are negations if their truth values are always opposites. So, what has to occur for this conditional to be false? Now, we've talked about this many times before. A conditional is like a promise. If this happens, then I promise this will happen. And what would have to happen in order for me to violate my promise? Well, let's pretend I'm not buying me a car, but I'm buying my wife a car. If I have the money, then I will buy you a car. What would have to happen to really anchor my wife? Well, I would have to have the money, but not buy her a car. So, what has to occur for this conditional to be false? I have money, and I don't buy a car. Remember the rule for conditional. It's only false when T points to F. It's only false when the first part is true and the second part is false. So what can we extract from this? Well, let's try to do this generically. Generically, to write a conditional, I would just have to write P pointing to Q. Now, if I write that, then I'm defining I have money to be P and I will buy a car to be Q. So how would this statement translate? Well, here's the phrase I have money, so that's still P. And is a conjunction, but the other half of it is I don't buy a car. Well, statement Q is I will buy a car. So how can I write I don't buy a car symbolically? Negation Q. So what we can infer from this is that the negation of a conditional is that. In fact, let's go ahead and not only write that down, but verify that it's always true, not just this case. That the negation of a conditional is this conjunction. Are this conditional and this conjunction negations? That's what the last example is suggesting. But remember, it means something to be negations. It means that you always have opposite truth values, which means the last columns in your truth tables should be opposites. Now, you don't need to make the truth table for this one. It's one you need to have memorized. It's TFTT. We should make a truth table for this one though. One column for P and one column for Q. The negation will happen first, followed by the conjunction. You might want to pause the video and see if you can pop out this truth table really quickly. The first two columns would be given to you. True, 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 false, false, true, false, false. Negation of Q is easy. Look at the Q column and change everything. Here's the Q column, FT, FT. For the last column, I'll slow down briefly. We're going to do the conjunction rule, which is true if it's all true. And we're doing it to the P column and the negation Q column. So, looking at these two columns only, well, the middle column's in the way, so I'm just going to scribble it out. Looking at these two columns, are there any rows where it's all true? Yes, the second one is the only one, so it's the only T over here. The rest of the last column is false. And now we can answer the question, are these negations? Compare the last column for the conditional. Compare the last column for P, conjunction, negation Q. And if you notice, they are complete opposites. False, true, false, false, true, true, false, true, false. So if we wanted to state symbolically the negation of a conditional, we could say the negation of P pointing to Q is equal to, and I'm cringing using the equal sign, P conjunction negation Q. All right, I'm gonna do it even though it's not in the book. The equal sign is not the correct symbol to use when comparing two equivalent statements. The correct symbol is a triple equal sign, which literally means is logically equivalent to. It's been bugging me. But wait a second. If these are equivalent, then their negations should also be equivalent. The negation of the negation is just the original. In other words, if I stick a negation on here, it's almost like two negatives. They cancel. But what would I get if I stick a negation on this? Let's whip out De Morgan's law. If I stick a negation in front of the conjunction, I would distribute the negation and change the conjunction to a disjunction. If I distribute the negation, P becomes negation P, but negation Q goes back to being just Q. So we can actually get two things from this part. The negation of the conditional looks like that, but a conditional on its own can be rewritten as a disjunction. A conditional can be rewritten as the disjunction of, here comes some more vocabulary, the negation of the antecedent and the consequent. That's a mouthful. All right, so we do have a way to negate a conditional by turning it to a conjunction, antecedent, conjunction, negation, and consequent. But a conditional on its own is equivalent to a disjunction, negation of the antecedent, disjunction, the consequent. By the way, on your test, I would give you those two statements there that my big finger's pointing to. And I would also give you both of De Morgan's laws.